it is given that a small ball is suspended by a thread of length L at the point O on the wall, forming a small angle alpha with the vertical. So over here basically we are having a pendulum bob, and take it as mass of this bob is nothing but m, and it is kept near to a wall, and this wall is making some angle alpha with respect to the pendulum bob, normal position of its pendulum bob. Now the thread will be with the wall has deviated through a small angle beta. Now this thread is deviated from its position by an angle beta in such a way that the value of this beta is more than that of alpha, and set free. Assume that the collision of the ball against the wall to be perfectly elastic. Find the oscillation period of such a pendulum. So our aim is to find out what about the value of its time period of oscillation. So first this pendulum bob will move from its extreme position to mean position, then from mean position to an angle alpha. It will make a collision with the wall, and as the collision is perfectly elastic, whatever may be the velocity with which it is making a collision, with the same velocity this bob will come will get reflected, and it will come back to its mean position again to its another extreme position. So we can just say that this object is in periodic motion, but not exactly in a simple harmonic motion. But we can observe that from its extreme position to mean position, it is following an actual simple harmonic motion. So time taken by this particle, suppose if we can divide it into two parts. One is time taken by the bob to move from extreme position to mean position, then let's say it is t1, and time taken to move from its mean position to alpha is taken as t2. So total time period will be equal to nothing but 2 times of its t1 plus t2. So basically we can find out the value of t1. So t1 is basically the value of time taken by the particle to move from extreme position to mean position, that is basically t by 4 if t is the total time period of oscillation. So total time period of oscillation, we know the value of t. Over here the value of t will be equal to nothing but 2 pi into under root of L divided by G. Now we can find out what about the value of T2. Here T2 is nothing but the time taken by the particle to displace from its mean position to an angle that is equal to alpha. So if this pendulum is displaced, start oscillating from its mean position, we can write the equation for it, that is theta is equal to nothing but it's theta naught into sine omega t. So you can write over here this theta is nothing but alpha, which is equal to theta naught, which is nothing but beta into sine of omega into t. So we can write the value of this one, that is alpha divided by beta is equal to sine omega, let's say time we just consider as t2, omega t2. So we can address omega t2 is equal to nothing but sine inverse of alpha divided by beta. And for a pendulum, we know that the value of this omega is equal to nothing but root of G divided by L. So the value of T2 can be written as nothing but under root of L divided by G into sine inverse of alpha divided by beta. So we can find out what about the value of total time, that is 2 times of T1 plus T2, which is nothing but 2 times of T1 is 2 pi into under root of L divided by G divided by 4, plus T2 is nothing but under root of L divided by G into sine inverse of alpha divided by beta. So you can write it as T is equal to nothing but 2 into under root of L divided by G into pi divided by 2 plus sine inverse of alpha divided by beta.